Hello everyone, this is GV Srinivasrao. Welcome to my channel. The present topic is Chemical Kinetics Module 4. In this module, let us learn to derive the integrated rate equations for zero order reaction and first order reaction. Please subscribe to my channel, share and like. Integrated rate equations. We discussed about the concentration dependence of rate and it is called differential rate equation. Instantaneous rate is calculated by the determining the slope of the tangent drawn at any point of time t to the graph between the concentration versus time. But it is not convenient to determine the slope of the graph every time and hence order of the reaction may not be determined easily. In order to avoid this difficulty, differential rate equation can be integrated to give a relation between directly measured experimental data, that is concentrations at different times and rate constant. Integrated rate equation is used to determine the rate constant. It is also helpful in calculating the time in which the reaction is 25% complete or 45% or any percent complete or vice versa. Now let us discuss integrated rate equation of a zero order reaction. Integrated rate equation of a zero order reaction. Let the reaction be R gives products. This is the zero order reaction. Now, what is the rate? Rate equal to minus dr by dt is equal to k into r to the power 0. Here r to the power 0, 0 represents a zero order reaction. So this is zero order reaction. This is called differential rate equation. Differential rate equation. And of course we know that r to the power 0 equal to 1. That is anything power raised to 0. So anything power raised to 0 is 1. So r to the power 0 is 1. So let us substitute r to the power 0 as 1. So this is minus dr by dt equal to k into 1. Now rearranging minus dr is equal to k into dt or dr equal to minus k into dt. Now let us integrate this equation. Integrating, this is number 1. Integrating equation number 1, we get integration dr is equal to minus k integration dt. So this is nothing but r is equal to minus kt plus constant. Minus kt plus constant. When time t equal to 0. Time t equal to 0 means reaction is just started or about to start. So time t equal to 0, R is nothing but initial concentration of reactant is nothing but R0.
right? So keep this, this is number 2 equation. So therefore number 2 becomes, if we substitute this value here in number 2, R0 is equal to minus k into time t is 0 plus constant. Therefore integration constant is equal to R0. So this is number 3. Now substitute third equation in number 2. So put number 3 in number 2. What is number 2? R equal to minus kt plus constant. But what is constant? R equal to minus kt plus R0. Now this becomes, bring this to this side, R0 minus R is equal to kt. R k equal to 1 by t into R0 minus R. This is the integrated rate equation. Integrated rate equation for zero order reaction. So this equation, all zero order reactions obey this equation. So if we know values of R0 at time t, that means R0 and R at time t, initial concentration and a concentration of reactant at time t. If we know these values, we can find K value. So integrated rate equation is R equal to R0 minus kt. So if we plot a graph, if a graph is plotted taking t on x-axis and r on y-axis, the graph comes as, this is time t, this is concentration. The graph comes in this manner. So this is the y-intercept, and of course it is R0, initial concentration. Now let us derive the integrated rate equation for the first order reaction. A hypothetical reaction is R gives products. Okay. Now, if R0 is the initial concentration and R is the concentration at time t, then time t. Now we have a rate. Rate is given as minus dr by dt is equal to k into r to the power 1. This is the rate in terms of disappearance of reactants. Because reactants are disappearing, the minus sign is shown. So rate equal to rate constant into concentration of the reactant raised to the power 1, because this is the first order reaction. Okay, rearranging minus dr by, bring this r this side, is equal to k into dt, minus dr by dt. So this is number 1. Integrating equation number 1. So integral minus dr by r is equal to k into integral dt. Integration minus dr by r becomes minus ln r. ln means natural logarithm, is equal to k, dt becomes t plus constant. We know that at time t equal to 0, R concentration of R is nothing but R0, which is nothing but initial concentration. So when we substitute T is 0 in this equation, so minus ln R0, because in place of R, let us keep R0. R0 equal to K into time T is 0 plus constant. Therefore, constant equal to minus ln R0. Now substituting the value of constant in, what is this, minus ln R equal to kt plus constant. So in this equation, let us substitute this value. So minus ln R is equal to kt plus constant value minus ln R0. So bring this to this side. ln, this is equation number 1, let us say. ln R0 minus ln R is equal to kt. So this can be written as kt equal to R ln R0 by R0 is equal to kt. Now this natural logarithm can be turned into base common logarithm. So this is number 2, changing natural log to common log, we get 2.303 log R0 by R is equal to kt. Or k equal to 2.303 by t log R0 by R. This is equation number 3. So this is a integrated rate equation for the first order reaction. Now significance of k, that is rate constant. This gives the fraction of the reactant converts into product in a unit time. In unit time, how much fraction of reactant converts into product, that is shown by the constant of the integrated rate equation. Now let us see the significance of integrated rate equation. if R0, that is initial concentration, concentration of R at time t are known, then K value can be found. K value can be found. Not only that, integrated rate equation of the rate equation can be used by finding the order of the reaction. Integrated rate equation is used to find order of the reaction. Order of the reaction. How? Substitute the values of R0 and R in the integrated rate equation. That is K equal to 2.303 by T log R0 by R. In this equation, if these values are substituted and K gets a constant value, then it is understood that the reaction is first order reaction. Otherwise, it is not the first order reaction. This integrated rate equation can be used to evaluate the K value by graphical method.
We conclude this module here. Thank you.